Okay, we've done this a lot, but just to go over it one more time, I want to talk about how a weak base puts hydroxide into solution. So I'm going to start with a generic weak base, B, and the way a weak base puts hydroxide into solution is through a hydrolysis reaction. That means reacting with water. So the weak base will react with the water it is dissolved in. It will mostly stay as the weak base. This is a reactant-heavy equilibrium. That's why it's weak. But some of the weak base will react with the water, removing an H plus from the water molecule and forming its conjugate acid that leaves hydroxide. And so that's how the weak base gets hydroxide into solution. Let me do a couple of them just as an example. Ammonia, we've done ammonia a million times, so I'll make it methylamine. CH3NH2 is an ammonia derivative called methylamine. It is a weak base. These things are aqueous. They're dissolved, they're just not dissociated. Weak bases don't dissociate. They hydrolyze, they react with water and remove an H plus from the water, but they don't dissociate, but they are dissolved. So this weak base will react with the water which it is dissolved in and pull off an H plus to form its conjugate acid. And that will leave hydroxide. And so that's why they make the solutions that they are in basic. Here's another example of a different type of weak base. Fluoride is a weak base. It is the conjugate base of the weak acid hydrofluoric acid. It will also react with water, giving us the conjugate acid, HF, and hydroxide. Okay, so let's notice that all of these reactions are balanced as to mass and as to charge. The top reaction up here is neutral on both sides. The second reaction, neutral on both sides. Both of the reactants for these two are neutral, and the products are +1, -1, so it adds up to 0 on the right. Down here, this reaction is also balanced as to mass and charge. Fluoride has a charge of -1. Water is neutral. HF has a charge of 0. It is neutral. Hydroxide's -1. So -1 on the left and the right. If you tried to write this last equation like this, without charges, it is wrong. Okay? Fluorine atom won't do that. And there's no such thing as an oxygen-hydrogen neutral molecule. So this is just wrong. Wrong, 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 wrong. Okay? So make sure you have the correct formulas and you have everything balanced as to mass and charge. Hope this helps.